Hey guys, today we are going over our last notes for topic 4, and it is on average rate of change. And that will be on page 26, and it should just be the one page of notes. Okay, so we will be doing average rate of change on the 19th and 20th of November, and the learning target is that I can find and interpret average rate of change. Okay. So what is average rate of change? So average rate of change is the rate of change over a designated interval. And I know what you're thinking. You're like, well, wasn't that what we were doing before? Well, yes, but actually there were all these different rates of change, potentially, unless it was constant, then it's always the same, but all these different rates of change happening. For example, the non-constant. If they're non-constant, then we need to find the average. So if you think about driving your car, you aren't always going exactly 35 miles per hour. Sometimes you might be going slightly over, sometimes you might be going slightly less, but then when you calculate the average over the time period, you can find out, oh, the average over that time period was 35. In fact, you could find that sometimes the person was driving 20, sometimes the person was stops, their average rate of change was 0. Sometimes they were on the freeway, so they were going 50 or 60, but when you average it out, it only ends up being 30. Okay, so what it is it's taking this time interval with all sorts of things happening and finding what would happen if you did go a constant rate of change the whole time. Well, remember, a constant rate of change is a straight line. So essentially, we're pretending that there is a straight line over this time interval where there doesn't actually exist a straight line. Okay? So I know that sounds a little confusing, but once I show you on the graph, you're going to go, oh, that makes sense. Okay, another thing I want to go over real quick is describing movement, because I think people were struggling with that a little bit. So when you describe movement, we're looking for some specific things that we wrote in the notes last time, but now I'll just lay it out for you. So again, starting and ending distance or location. So where did the person start or whatever, car start, in reference to our, motion detector or the house or whatever, and where did they end? Sections where it's constant and where it's not constant, okay? Because you can have graphs, like in the waterline graphs on Desmos, where sometimes you're partnering a curve with a straight line, in which case you have sections that are constant and sections that are not constant, and you want to point that out. You want to tell me or describe whether they're moving away or towards, or the combination, like when they're doing each, and then also if there's a change of direction and when. And then lastly, describing the speed. So like, are they going slow to fast in a section? That would mean they were speeding up. Are they going fast to slow in a section? That means they'd be slowing down. Okay? So those are just some things that you want to make sure to include, because I think that people were not incredibly sure how to tackle a problem that just says describe the movement. Okay, so you want to make sure that you're considering these things. You won't always have to mention everything, because sometimes there won't be a constant part. It'll all be not constant. Sometimes there won't be a change of direction. Okay, they might be moving toward the entire time. Maybe the whole time they're going fast to slow, so it's slowing down. So, but the point is that you want to consider all of these options or scenarios. Okay, so now the rest of the time, I want to show you, well, how do we find rate of change? And then we might go into these depending on how much time we have. But how to find the average rate of change. So again, we have graphs. Now, if you want these graphs, they are on Canvas under this assignment, and they have these. So you can actually print them if you want to, or you can use them to look at in a little bit more detail so that you can recreate them. What's really, really important are these transitional points. And what I'm going to do is pause real quick and add in the points, because you can see here, this one's labeled and this one's labeled, but nowhere else is labeled. So I'm going to pause, add in those points, and then unpause. Okay, so here are the points with labels. Okay, and you'll get to see them more closely as we do each one of these. I do want to just point out a difference real quick before we get started. This middle graph here is by fives. okay? And then I just found out that this is scaled incorrectly, which is kind of upsetting, but, well, too late now. Anyway, but yeah, so that scale is different. So just use the numbers I used. We'll figure it out. And now the other two are by ones. And this is cut off over here, but it's always time in seconds and distance in feet. Okay? So let's go ahead and focus in on graph 1. Whoopsie daisies. Okay, so this one we've called each section a letter. So this first section here from 0, 1 to 3, 4 is called A, then B, C, and D. Now, you can tell that all of those, all 4 of them, are constant rates of change because each little section is a straight line. Okay, so what we're going to do is find the rate of change in each section. And for each section, again, it's a constant rate of change. So what we're going to do is rate of change for each section. Okay. So we're going to start with A. And remember, rate of change is always change in the dependent variable over the change in the independent variable. But for graphs, I like to say rise over run. And remember, rise can actually be down, which is confusing. But okay, so for A, I'm just going to put a colon, okay, because it's not, A is not a number, it's just a section. So we have rise over run. Okay, so we need to be careful because if we start to do too much here, we're going to notice that this is going to get real crazy. So I'm just going to kind of do a dash line. So you want to start at the beginning point and end at the ending point, which is 0, 1 to 3, 4. So I'm going to go up and over. Okay, so the amount I go up is 1 to 4, or 1, 2, 3 squares. So that rise is plus 3. And then because that is along the y-axis, that is distance in feet. Okay? Now this other part, the horizontal movement, is over from 0 to 3, right? Because we started at the 0 and we went over. So that is also 1, 2, 3. So plus 3. And then because that is parallel to the x-axis, that is time in seconds. So we're just going to write 3 seconds. Okay, now we actually do the math. So we do 3 divided by 3, which is 1. Okay, and then feet per second, which we can actually abbreviate really nicely to FT/S, which is just the shorthand for feet per second. So if the person is walking, they're going 1 foot per second. Okay? Okay. Now let's do B. Sorry, I'm just picking out the color. B. Section B. So for section B, again, we're going to do rise over run. You're going to get so sick of it, and then we'll do it in the next chapter, and you'll get sick of it. Okay, so this time, again, we're starting at 3, 4, and we're going to 5, 5. So we go from here and then over to here. So the rise part of this, the up or down part, is actually just 1 square. So that is plus 1, and then remember, since it goes parallel to this, it's feet. And then divided by or over, and then it goes over 2 squares. So plus 2 seconds. And that means 1 divided by 2, you can leave it as 1/2, or you can make it 0.5 or 0.5 feet per second. So they have slowed down because that is less steep, or it has a lower rate of change than A. Okay, now we get into the difficult part. From C, the section C here. Oopsies, I went a little too high. Okay, for section C, rise over run Well, you actually just go straight across. There is no up or down. Since there's no up or down, that's 0 feet. And then we went over 2 seconds. Well, 0 divided by 2 is 0 feet per second. And if you think about it, that makes sense because it's a horizontal line. And we know that when there's a horizontal line, there's no movement, right? So they didn't go anywhere. Thus, they traveled 0 feet per second. And now the last one is section D. Rise over run. Now this is the first time we're actually going to be going down and then over. So since the rise, quote unquote, is down 2, we're actually going to write -2 feet. That's why I've been writing plus this whole time, is because sometimes it's down. And then we still go to the right because you're always going from left to right. So this is going to be plus 1 second. Okay? So the -2 divided by 1, which you can use a calculator if you want, but that's -2, and then feet per second. Okay, so remember, this is to find rate of change and interpret it. So we found some rates of change, right, or average rates of change, which is over these intervals. The special part of these intervals is that they are already little sections of constant rate of change. We can tell by them that the slowest time, besides being standing still, is 0.5 because it's the smallest rate of change, so it's the slowest time and it's the least sloped or least steep. Then, even though technically this is a negative number, 2, if you ignore the negative, is higher than 1. So this last section D is the fastest. It's just going down. And then lastly, because this is negative, that means that they're returning toward wherever the origin was. If they were like walking from their house, maybe they started 1 block or foot from their house and they're going back there. So in this one negative section, they're going back, and these 2 positive sections, they're going away. Okay, but now let's focus on average rate of change because these were all small intervals. Well, what happens when we look at the overall interval? So, average rate of change. Okay, so what I want to do is pick an interval because it's the change over an interval. So I'm going to go from the very beginning, 0 seconds, to the very end, which is 8 seconds. How do I know that? Because it ends right here, which is, if you draw a line down, that's 8 seconds. So let's do it from 0 to 8 seconds. So I'm going to write rise over run, but then I have to go up to the graph. Rise over run. Okay, so I'm going to keep that there. I'm going to go on up now to here. So what I want to do is remember, we're essentially saying, yes, there's all this stuff that happened, but what if someone just did 1 speed the whole time, or essentially we average out the speeds that are happening here to find the average, because there's like faster times, there's 0, there's negative, there's positive, but what is happening overall? Well, so we are going to create a straight line where there wasn't one. So I'm going to take this and connect here. There wasn't a straight line there. Now there is a straight line there. Okay? So, create a line. So what we want to do now is we have to go up and over from our starting point to our ending point, and we kind of just ignore that all these other things actually happened. So we're going to go up, and sorry, I'm only going over a little bit so you can distinguish between the orange, and then over. Okay, so it looks like we went from 1 to 3. That's 1, 2. So plus 2 feet. Over. And now we have to count how far we went over. 1, 2, 3, 4, 5, 6, 7, 8. We went over 8 squares. So that is 8 seconds. Oopsies. That's what happens when you don't pause. Okay, so now we actually have to divide. Now, if you do 2 divided by 8, you're going to get 0.25, or a quarter of a foot, feet per second. So whoever went on this walk did a whole bunch of different rates of change. They started with 1 foot per second, then they switched to 5 or half a foot per second, then they stopped moving, and then they went the other direction at 2 feet per second. If you wanted to start at the same time as them and end at the same time in the same place, you could have just walked a quarter of a foot per second the whole time, and you would have ended right at the same location. It is the average. If you accumulate all of these together, it would average out to be a quarter foot per second. Now, please don't just go, oh, we add these together and divide by 4 like an average. No, it doesn't work that way because some of these sections are longer than others. The section A goes from 0 to 3 seconds. The section B has 2 seconds long. The section C is 2 seconds long. Section D is only 1 second long, which means you can't just add them up and divide by 4, unfortunately, but it does work out to be this. Okay? And you can do that between any 2 points. For example, let's go from let's see here. I gotta pick a new color, Azor. Let's go with purple. It's kind of close to blue, unfortunately. From 3 to 7 seconds. You can kind of tell the difference. This is purple, y'all. Sorry. Okay, from 3 to 7 seconds. So let's go back up to our graph. So 3 seconds is this point here because it's in line with 3 seconds. And 7 seconds is this point here because it's in line with 7 seconds. So what I want to do is connect those two, okay, right here. Now that includes section B and C, okay? So we can find the average rate of change here by going up and over. So we only went 1 square up, which is 1 foot, and we went 1, 2, 3, 4 over. Okay, so we have plus 1 foot over 4 seconds, which actually also ends up being a quarter foot per second. Dang, that's a fluke. That does not always happen, I promise. Okay, I'm going to go on to the next one, but the reason that worked out is because if you look, these two lines were parallel. That's why. But that's what it means to be for an average rate of change. It means to kind of ignore what was happening and pretend that you just went a constant speed the whole time. What would that be? And the way you do that is put a straight line between them and calculate it. That's it. Okay? So why don't we look at this one? Now, this one's a little different because instead of being the sections being called A, B, C, D, each point is A, B, C, D, E, F. Okay? So we're not going to do all of them like we did on this one because that'd be a lot. But let's just do, we're just going to do average rate of change. Oh, I know. Guys, I have an idea. Why don't you guys find on your own from 0.027 seconds. And it will not be 0.25. Okay, so go ahead and do that one on your own. It will not be 0.25. Okay, sorry guys. In fact, it's probably some weird decimal, but that's okay. Okay, sorry, back up here. Rate of change. Average rate of change. Okay, so we could find the rates of each of these lines, but I again want to show what happens if we do different sections. So for example, sometimes they'll say, what is the average rate of change of the entire journey? Okay, when they say that, they mean from the starting point to the ending point. So this means from point A to F. Okay, and you're actually going to see something really weird happen. So to do this, from A to F, okay, we want to again do rise over run. And notice that A to F is just a straight, flat, horizontal line. And if it's a horizontal line, then when we do rise over run, notice that I don't go up or down at all. That's 0 feet. And how far do I go over? Well, remember, this is by fives, so we actually get up to 50 seconds. Well, what is that? That is 0 feet per second, because 0 divided by 50 is 0. So even though this person had a whole lot of movement, if you just stood there and did 0 feet per second the whole time, the result would be the same. If you averaged all of this movement out, the average is that you're in the same place at the end. Okay? So another idea is we could do from point B to D. Okay, you're going to see we're going to go down from B to D. I just dropped a pen. That's okay. Okay, so from B to D, rise over run. So this point up here is B, if you're wondering, A, B, C, D, E, F. And again, if you look at the PDF, you can see those a little better. They're kind of fuzzy. So I'm going to connect the point B and D because I'm going to pretend that there was a straight line there the whole time. And what I need to find out is how much do I go down and how much do I go over, or my rise over run. Since it's down, it's going to be a negative. And remember, this is by 5. So 5, 10, 15, 20, 25, 30. So that's negative 30 feet. I know what you're thinking. How do you have a negative distance? It's not negative as in like you owe someone 30 feet. It's negative as in it's a direction. It's going down or toward if this is the person's house. And then how far are we going over? 5, 10, 15, 20 seconds. Okay. And then if you use a calculator or you just know it, that is negative 1.5 feet per second, which means that this person was standing still for a bit. I know that because it's horizontal, and then they went really fast because that's a lot steeper than this is. But if for this whole time period you just went 1.5 feet per second toward the desired location, you would end up at the same place. It's the average of those two movements. Okay? So, why don't you guys find the average rate of change for C to E and from A to D. I feel like we got room. Let's just do one more. And lastly, from C to F. And I noticed I started doing dashes instead of the word to, but that's fine. Okay, so go ahead and try those on your own. Remember, it's rise over run. Some of these will be negative and some will be positive. I'm hoping that they're not like a third, but if they are, you can always leave it in fraction form, guys. It's not a big deal. Okay? Okay, so I feel like those are a little bit easier than when we introduce something like this last graph, graph 3. So now, on these other ones, each section was already a constant rate of change. Well, this is not. This is non-constant because it's curved all the time. Okay? So you really can't even tell me the constant rate of change between 2 points. So we really are doing an average of a whole bunch of different ones. So it's really nice just to be able to draw a straight line and calculate it. So what we're going to do is the same thing before. It's just weird because there's already a curve there. Okay, so we're going to find the average rate of change from, and I'm going to go back to referring to these in seconds because there's no letters associated with them. So for example, let's do from 0 to 2 seconds. Okay, and we'll always refer to it in seconds because that's the independent variable. It's the one in control. So you want to use those to describe your area or section. So we look at rise over run, and we again want to connect. Here is 0, so we must mean that point, and 2 on the x-axis corresponds to that point. So we connect those, and now I actually want to figure out what is my rise and my run. Okay, because there's not actually a nice little constant right here. We have to figure out what it would be. So here you can see we're going up 4 and over 2. So that is plus 4 feet, because again, that is along the y-axis, over and then to the right, so plus 2 feet. Well, 4 divided by 2 is 2. Oh my gosh, Azor, seconds. There we go. So 4 divided by 2 is 2. Feet divided by seconds becomes feet per second. So that is the average of the speed that's happening there. Okay? So, you know, most of us don't actually walk at an exact constant rate, but in this section, if you were to average it out, that was the person's average walking speed in that section. But now let's do from 2 seconds to 8 seconds, which is this span here. Okay, you can't really even see my line almost. There it is. Okay, and it is a lot less steep than that first one is, isn't it? And so we're going to go up and over, and that's rise over run. And so we're actually only going up 2. We're going from 4 feet to 6 feet. So that's plus 2 feet over, and then 1, 2, 3, 4, 5, 6, 6. So plus 6 seconds. Aha, that is actually 1/3. 2 divided by 6 is 1/3. So if you have your calculator, you're going to get 0.333333. Let's just round it to 0.33. 2 decimals is fine. So 0.33 feet per second. Okay, so that is what is going on there. Now I'm going to skip a point and go straight from 0 to 8 seconds. So what happens when we actually skip and go straight there? So we broke them into 2 parts, but there is an average over the whole part too, because you went faster and then slower. So my hope is that it's actually in between these 2 numbers, but we'll find out. So that is from 0 to 8 seconds now, which is rise over run. Okay, so if I'm looking at these, I got to go up, 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 up. I got to go past that blue one. And I got up to 6, so I went from 0 to 6, and then I'm going to go over. And again, the reason I'm kind of drawing it off is because I don't want to go over the top of the thing. And we go over 8. So we went up 6, that's plus 6 feet, and then over 8, which is plus 8 seconds. Okay, well, that actually ends up being 0.75, or 0.75, that's 3/4 feet per second. Hey, and it actually was in between those 2 things, which is kind of cool. Okay, so that's it. The curve part might look scary, but it's actually the same thing, and we're just drawing lines in between them. The hardest part is probably determining where to look when it tells you certain seconds. If it helps, do it in pencil, draw the stuff out, and then erase it so that you have a nice clean slate. So there's a few more things that you can find out here, so I'm going to give you just a few to try on your own. So you can also do from 8 to 10 seconds. We have from 2 to 10 seconds. And you probably guessed it, the last one from 0 to 10 seconds, which would be considered the entire journey, if you remember that terminology. So when they say the entire journey, they mean the whole time span. Okay, so go ahead and find those. I think you'll find that this one is actually really, really nice. You'll be like, oh, really? That's the number? And then notice that none of these should end up being negative because it's increasing the whole time, so all the rates of change will be positive. Okay? So that's all average rate of change is. We will look at it and interpret it next time in class. Okay, see you then.